Hi guys, welcome to the fourth part of the video with me, Dr. Shida. So in this video, we will explain to you about the concept of buoyancy and stability. So in our daily life, we can see that some object floats while some object sinks. So how does this happen? This is due to the presence of buoyant force Fb. Okay, buoyant force Fb. So buoyant force Fb creates an upward force to lift bodies in water. Like as shown in this diagram, the buoyancy of water will cause your sponge to float, although there is a gravitational pull that wants to push down the sponge to the bottom, but buoyancy keeps it afloat. Okay, even in the wooden block it will float, but in some cases like this steel block, it sinks to the bottom. Okay, why some object floats and some object sinks? So Archimedes states that when weight is greater than buoyant force, the body will sink. So when weight is more than buoyant force, object sinks. Weight less than buoyant force, object floats, like shown in this image here. So when buoyant force is more than the weight, our object float. Our object will sink when the buoyant force is lesser than the weight. Okay, let's move on to the next slide. So Archimedes' principle states this: the buoyant force acting on a body of uniform density immersed in a fluid is equal to the weight of fluid displaced by the body. So buoyant force is equals to the weight of the fluid displaced by the body, and it acts upwards through the centroid of the displaced volume. So let's say this is our object. We have a centroid there, so that is C, and then you place your object into water, into this flask. If you notice, the water surface is just right through the nozzle. So once this object sinks into the water, the volume, the surface of the water increase, and the excess water comes out. So when the excess water comes out, this is said to be the weight of the water displaced. This is water displaced. Water displaced due to the object. So the weight of the water displaced should be equals to Fb. So Fb equals to weight of fluid displaced. This is according to Archimedes Law. Now let's look on the force of equilibrium. So to have our object here floating, it should have like some forces acting on it, right? So we have, because this object is in water, it is subjected to the surface, is in contact with fluid, so there are hydrostatic forces acting on it. Okay, so on the top surface we have rho g s a. So top surface of flat plate is the hydrostatic force acting on it is denoted with this, and then acting downwards. And at the bottom we have fluid as well surrounding the bottom surface, which is in contact with the bottom surface of the flat plate, and we can denote by rho g s plus h a. Why is for the bottom we have s plus h? and the top we have just S. This is because at the top surface the height from the surface of water to the top surface of flat plate is S, but for the bottom surface the height is actually S plus the thickness of the plate H. So forces of equilibrium give us FB, our buoyant force, is equals to the difference between hydrostatic force in the bottom surface minus the hydrostatic force in the top surface. And then using this formula, rho GS plus HA minus rho of fluid GSA equals rho GHA. So this component here is height times area of flat plate, so we can get that as volume. So FB is rho FGV. So this is from the equation of equilibrium. Equation of equilibrium. Of forces. So Archimedes law Archimedes principle give us this equation. FB equals to weight, which is should be weight of water displaced, okay, is equals to our buoyant force. For static equilibrium just now said that FB is equals to rho G V. Okay, so V sub is actually the submerged portion of the volume. Why submerged portion? Because in some cases, let's say you have your fluid in the tank. In some cases, the object floats halfway. The only part that submerged in water is the same portion as the volume submerged. Okay, if the object is completely submerged, then we know we can take the whole volume. So this is partially submerged. Okay, for the sink one is the same as this one. Okay, so from these two equations we get FB is equals to weight, which also equals to rho G V submerged, or equals to rho GV total. So submerged and total volume. So we can get this ratio where V submerged over V totals is equals to V average, rho average of body over rho F. I will show you later what is the function of this formula here. So we get this relation from here. So always note that our buoyant force is acting through the centroid as well as the weight of the body. So from Archimedes principle states that the volume should be the same, right? So same as the fluid should be acting at the center. Okay, so this is the relation just now. We have the submerged volume fraction of floating body is equals to the ratio of average density of body to the density of fluid. When the density ratio, which is this one, is equals or more than 1, floating object will become completely submerged. So we see our row of the object is less than row of fluid, our object will float. When the row of fluid is equals to the row density of the object, it will be suspended body or neutrally buoyant, so it either will stay there or sink. So when the density of body is more than density of fluid, our object will sink like this. So this relation will tell you that this object here should have the density ratio either equals to 1 or more than 1 for it to sink. Okay, now let's move on to the next one. So just now we have covered buoyancy. Now we are going to understand the concept of stability. So buoyancy concept deals with object floats or sinks. But when it comes to stability, we want to know whether our object can remain there stably. Okay, is my object stable? Yeah, so this is important when it comes to application like ships. Okay, you don't want, let's say you have this is your ship in water. So this is your ship in water. We want the ship to remain stable. We don't want it to rotate or topple. To remain stable, no rotates, no topples. Okay, stable, no. So for what other things we have? Ships, we have hot air balloon. This hot air balloon and submarine. So these three applications are using the concept of buoyancy and stability. Okay, so in order to understand stability, we can look at this diagram here. Okay, when the object is stable, like in case A, any small disturbance generates a restoring force that it returns to initial position. Let's say our ball is on this ramp. So if you push it, it will start to move, but then it will go back to its original position. When neutrally unstable, we can imagine our ball is on a flat surface. So for neutrally stable, if someone moved the ball to left and right, it would stay put at its new location. It won't go back to its original position. Okay, so for an unstable case in which the ball may be at rest at that point, but then with any small or slight disturbance, it will roll off the hill. So it will not move back to its original position. Okay, so this is the concept of understanding stability. We have three cases: stable, neutrally stable, and unstable.